Hello everyone, welcome to the College Chronista presentation on Relational Database Management System Introduction. Again, this is an introduction course which will familiarize few of the concepts that you might have learned in the college about what is DBMS, how it evolved, and then what are the key concepts involved in database design. So the first brief history about database management system. Before the database management system was invented and made use commercially, most of the things were stored in file. And these files, the records in these files were indexed with the basic indexing mechanism and basic search operations and sorting operations were performed on these records. So if you look at the older systems like mainframe, most of them are like indexed files actually, which was sort of a primitive database that was used earlier. And then business and requirements actually became more complicated, and almost all the companies required a comprehensive system to manage their data, and that's when DBMS started to popularize itself and became widely adopted. So here are a few of the databases that are a database management system. Not all of them are relational database management system. Okay, but few of the ones that are still being used widely and then for a long time. Informix is one of the popular database management system. And then IBM DB2, which started with mainframe, and then eventually it was ported to, I guess, AS400, the I series, and then to I think they even made it available to other non-mainframe platforms. And then Oracle, which was a project sponsored by some government agency, and then they abandoned that project, but I think Larry Ellison took over that and started to commercialize it, and it became Oracle. And then Sybase is another database management system, which was I think is a joint venture between Sybase and Microsoft, because Microsoft initially didn't have a database server on their own, so I think they joined hands with Sybase. And then later on, Microsoft SQL Server started, and then a slew of other small database systems, open source, free and open source, started, like MySQL, PostgreSQL, and other things. So this is a brief history of DBMS. So I request everyone to go over these databases in Wikipedia articles and other things, so that you can understand who owns them, which is free, what are the licensing terms, and other things. Okay. And again, this is the evolution in which the DBMS system evolved. So everything started with flat file, and then we have a hierarchical database management system, which is like a monolithical tree-like structure stored on the same server. And then came the network DBMS, which is sort of a distributed database management system where parts of the database system was on different servers, and also you can connect to them from other platforms and other things. And then relational database management system, this is the biggest milestone, where you have solid programming language was introduced to manage, query the data, explore them, and do various operations on them. This is the major breakthrough. And then came the XML. So even though it's not a popular hit, but still XML database management systems were a short-lived database. So even now people use XML DBMS concept in their application for offline storages. And then came the object-oriented relational database management system, which ported the object-oriented concepts to the database world to increase the reusability and other things. And finally, NoSQL. So NoSQL is, initially it came up as not SQL. So they had their own, like a rebel movement. They had their own philosophies to justify that the RDBMS systems, SQL-based ones, are really best and all those things. But finally, when they started to run into a lot of other problems, they understood, okay, the people who developed SQL were wise enough, and then they modified that to be not only SQL. So it is still SQL plus other additional concepts, and these are becoming more popular for few of the reasons. One of the key things is obviously a distributed storage and processing mechanism, and also in today's world, the way transactions happen should not affect the scaling and other things. So these type of databases have figured out a lot of other problems that users are currently facing with RDBMS, and they came up with this. Uh, so this is about the evolution of DBMS. So you can go through more about these in some articles if you can. So let's move on to the next. Okay, so the relational database management system, or even DBMS, I would say, is mostly based on set theorem concepts used in mathematics. If you have studied set theorem, you should be able to program in the database world with much better ease. Okay, some of the set operations are directly used in a database, like unions, intersections, complements, Cartesian products. So highly recommend that you take your school book and read more about the set operations. Okay, set and other things. So that way we know it will be easy for you to translate them into the database. Okay, so it's a must. So go through some set theorem concepts and other things. So almost all the database management systems today, that are available in the market today, especially the RDBMS ones that are using SQL, actually implement these cards 12 rules. Okay, and the cheat interview question is how many rules that cards 12 rules have. Okay, and the name apparently is misleading, or like it was modified later in the history. People would say 12, but it's actually 13. Okay, initially it was 12, but they modified and added one more rule to make it 13, and also they renamed the rule numbers to start from 0 instead of 1. Okay, so I'm going to go through in this presentation mainly these rules and explain what these rules are. So because this is what is asked in most of the interview questions, and again, for you to evaluate whether a system is a RDBMS system or not, you have to understand whether how these 12 rules can be validated, or how to check if a database management system has implemented this. Okay, again, most of these rules, if you look carefully, they are derived from set theorems. Not most, but quite a few of them. Okay, so you can see that. So let's start from rule 0. The system must qualify as a relational, as a database, and as a management system. Okay, so what this means is it should support relations, okay, between the data, and also it should be like a database system. Okay, so it should store data in an organized way and other things, and it should also provide a way to manage the whole system, not just the data. Okay, so that's what. So it's not just data, it's like I should be able to export the data, import the data, modify the data and other things. Okay, and even take down the system and bring it online safe, and how is recovery working, and how fault tolerant it is, and other things. Okay, so as a management system too. Okay, so if you are using file, for example, okay, so you can imagine that it, first of all, to establish a relationship between the data in two different files is a little difficult. And again, you can store the data, that's not a problem, but to manage it, the way you do it will be much more complicated. Okay, so as per the rule 0, if a database management system is a RDBMS management system, they should have all these three to manage things very, very easily. And rule 1, all information in the database is to be represented in only one way, namely by values in column position within rows of tables. Okay, so they're just saying that all data should be stored only in a 2D structure. Okay, even if it's a 3D, it should still be stored as 2D structure. Okay, and it should be addressed also in a 2D manner. Okay, so by column and the row number, I should be able to get it. Okay. Rule 2, it says that every individual scalar value in the database must be logically addressable by specifying the name of the containing table, name of the containing column, and the primary key of the containing row. So again, to get the rule, bottom line of this rule is that I should be able to pick up any value in any column and any row from a table. Okay, so and the way we specify it should follow this convention where I specify the table name, the column name, and the row that I filter or select using the primary key of the row. Okay, and rule 3, which is the DBMS must allow each field to remain null or empty. Okay, so it means it should not make all the fields required. Okay, so which was previously, I guess, the case with some of the file-based systems, where even if a field is null, you have to store as that many spaces in them instead of just leaving them blank or something, and the application has to kind of trim it or remove the spaces and other things. And then users must be able to access the database's structure using the same query language that they use to access the database's data. Okay, so this means to get the data from a table, I just say select star from the table name, and I select a database before that using use statement. What they are saying is, if I want to get the list of databases in a server, okay, I should be able to do that using the same query format. Okay, I should not write a C program or something else to actually get the list of databases from the server. Okay, so I should use the same SQL language to access even information about the server and the database. Okay. Rule number 5. The system must support at least one relation language that has linear syntax that can be used both interactively and within application program. Supports data definition operation, data manipulation operation, security and integrity constraints, and transaction management. Okay. To simplify that, it says that the system should support one programming language. That's the bottom line. That uses a linear syntax. Okay, not something like an event-based or something. Okay, as of now. And also it says I should be able to use this same language to interact with the database in the database management system as well as from any other application program. Okay, and that particular language should support data definition, which means I should be able to create tables, views, and other objects, and data manipulation, which means I should be able to insert, update, delete the data. And then it should also support some security things, which is like these particular users should not be allowed to access these tables, and also some integrity constraints saying like, hey, if I have the list of countries in this table, and all the other tables that have the country should have only values from these tables. Anything out of this should not be used. And lastly, it should also support transaction management, where I want to insert a bunch of records into a table or delete them or whatever it is. I enclose them into a transaction. If one of them fails query, it should roll back and leave the database in the previous clean state. Okay, so this is what is about Rule 5. Rule 5 really lays foundation for the programming language that is required. Okay, it's from now on it's going to set standards for the programming language. Okay, and then the other one is Rule 6, which says all views that are theoretically updatable must be updatable by the system, which means if a view is derived only from a one table, okay, and if I issue update statement to that view, okay, it should update the underlying table. Okay, if the view is getting the data from multiple tables, then again it's not possible. While some systems are smart enough to implement that with some limitations, but theoretically, if your view is derived only from one table, then obviously you should be able to update them using when you update the view, it should update the underlying data in the underlying table. Okay, and the rule 7: the system must support set at a time, insert, update, and delete operators. Okay. So you should be able to identify when a record was inserted, updated, and deleted. Okay, using this. So that means the DB should store a metadata about your data. Okay, so that's what it is, and they specifically explain what these should be. Okay, and rule 8 is a very, very important rule. Changes to the physical level must not require a change to an application based on the structure. Okay, so as you know, in data structures, okay, if there is if the records are of, like, say 100,000, maybe the data structure used to store that is something like an array, and if it's more than that, maybe it is a linked list or something like that. So the underlying data structure, when it changes, okay, it should not affect the applications that still use them. Okay, even I should be able to, no matter what the data structure, underlying data structure is used or how the data is stored, I should still be able to get the data using SQL, either interactively or from my applications. Okay, so this will happen whenever you scale a system, okay, or like a refactor a system or other things. Okay, so this is very important standard to make sure that this doesn't break any of the applications that depends on this, because if that is the case, then like we would be rewriting the applications like every new version of the database release, okay, major release. Okay, so that should be avoided. So that's what this rule 8 says. Okay, rule 9, changes to the logical level, which is like tables, columns, rows, and so on, must not require changes to an application based on the structure. Okay, which means if you add a column, this cannot be implemented 100%, but at least it's the best thing to have, which is like if I add a column to the table, or if I insert a row, or like if I add a new table to the database, it should not actually affect any of the applications that are using them, which is quite true when you add it, but when you delete it or modify, change the types, yeah, that tends to break the application. So this is like a partially satisfiable rule, not completely. Rule 10, integrity constraints must be specified separately from application programs and stored in the catalog. Okay, so which is like, as I told earlier, if you have the list of countries in a table, and all the other tables that are storing the addresses should reference the countries only from this table, and this must be stored in the database, and this should never be in your application. This integrity enforcement should not come from your application, it should come from your database. Okay, most of the times developers tend to code these things in applications, and imagine a company that has like 10 different applications talking to the same database, and each of them implementing their own set of integrity constraints will lead to a chaos. Okay, so these integrity constraints should always be in the database. Okay, first point. The applications can enforce them on offline before even inserting the records and other things. Okay, but still this should be stored in the catalog, not in the application programs. Rule 11, which was actually the last rule for the cards 12 rules. Okay, the distribution of portions of database to various locations should be invisible to the users of the database. Okay, so this makes it very obvious that you, like for example, your database file will be like 2 GB or 3 GB. and your hard disk might not have that much space, or like if it's 30 GB, it might not have that much space. So people tend to partition the database into different files and store these files into different servers or different hard disks or different partitions. But this should never affect the way the user interacts with the database or the applications interact with the database. That is why we need a management system, not just a database system. Okay, so that the management system will take care of these things. Okay, and this was the rule that was added as the last, which means like this is an additional rule that was not actually added by CORD. It was added by a group of people after CORD's 12 rules were established, which is if the system provides a low-level interface, then the interface cannot be used to subvert the system, which is I should not be able to modify the data using some low-level languages like assembly or something, okay, or corrupt the system. Okay, this is more of a security aspect of the rule, I would say. So the interface cannot be used to subvert the system. It means like they cannot create a corrupted or modified some server settings or other things using the low level storage. Okay, so even compacting the file, okay, or like creating a new partition or other things, they should still be able to do it via the SQL language, not really via some low level language that would manipulate it. Okay, so these are the CORD's 12 rules. Again, this is almost all the database interviews have at least one or two questions pertaining to this. Okay, some of them would be like, what is your favorite CORD rule? Okay, and what do you which rule do you think enforces relations and other things? So go over these 12 rules one more time, watch this video, and then you should be on your way to clear your interview questions in the basic RDBMS. So, under rough overview of other topics related to the database, okay, any modern database RDBMS system that you have will have at least these tables, which will have rows and columns, views, which is something we create on top of tables. The main reason we create views is for two things: one for security, other for reporting. When I mean security, which is like, for example, I have a application which is used by different departments in an organization. For example, a human resource, a project management, and a finance. Okay, and the human resource people doesn't, and the project management people don't need to see the employee's salary and other things. So most probably developers tend to get lazy and they use select star from the table name and they display it on the app, which should be avoided, so that we don't really disclose the information that is not needed or not allowed to the users. So in order to do that, the best practice is to create a view that will only have the list of columns that a particular group of users or role supposed to see. Okay, so that the applications that show the data to the HR people will get the data only from the HRB. Okay, or other things. So reporting side, again, there are a lot of you at sometimes to get the detailed report, you should be you'll be merging data from multiple tables, okay, and then showing it to the users. So most of the reportings are written as views instead of stored procedures, so that they can modify that easily. So views in essence is just a query on a set of tables, select only, that gets the data. Okay, so these are the two things for use. And then custom data types. Nowadays people need more custom data types like lat long and other data types. Okay, and then stored procedures. Most of the programming logic is written in the SQL language using stored procedures, and then some are written using user-defined functions. Most of the user-defined functions are really like reusable functions, where if the user passes a list of values separated by comma, we split them into a list of tables and return. And if they do it the other way, where if they pass the list of records, IDs, we club them into we merge them delimited by comma and then return it back as a string, and other things. These are written using user-defined functions. So these are at least the basic objects. Again, when we go deep into databases like MySQL and SQL Server, you will understand it much better. And tables, it can have these columns, these things. Columns, of course, you define what are the columns in the table, and then you will have rows, and then it can have primary key. Again, the primary key is a key which is set of, it can be either one column or set of columns too, where null values are not allowed for that column at all. Okay, and each value should be unique. Okay, this is what the basic definition for set says. Okay, and that's what primary key does. Okay, and then foreign key, as I said, if this table is storing some values whose master list is actually comes from some other table, we establish a foreign key saying, hey, list of countries should come from country table, so this country ID in this table should come from the country table. Okay, and it can also be the other way around. Okay, so and then unique key is almost like primary key. The only difference is one of the rows in the table can have null value for that unique key column, just one. Okay, in primary key even that's not allowed. Okay, and then clustered index, non-clustered index. This is a very, very, very basic interview question. I haven't had any interview without this question. Okay, so clustered index. So I want you to remember this PC. Okay, PC, physical clustered index. Okay, virtual non-clustered index. Okay, remember this. So clustered index is nothing but it's an index built. It is the index, or it's the way order in which your records are sorted and stored by the database management system. Okay, which is usually the primary key. Okay, when you insert a record or delete a record or anything, your records are stored in the database management system sorted by the primary key by default, physically into a file or some other data structure. Okay, so a table can have only one clustered index because it is the way in which the data is actually stored in the system, and it can be stored only one time. If you are storing the same data multiple times, again you run into a redundancy problem, which violates the very reason why people go for database management system. Your data should not be redundant in the database management system. Okay, so the clustered index can be only one. There can be only one clustered index for a table. Okay, and it is usually the primary key, and it is the order in which the records are actually stored in the data structure or the file in the database management system. The non-clustered index, okay, is actually it's called as, even can be called as a logical index, I would say. Instead of virtual, it can be called as logical, where even though your primary key column might be an ID, okay, which is like a 1 2 3 4 5 6 auto increment ID, your application, whenever it gets the records, it might sort the tables by first name and last name always. In this case, your query will run slow because the records, the database records are sorted in the primary key column, and to find out to sort the data in memory, okay, is by first name or last name can be time consuming. To avoid this, what the DBMS system provides is called non-clustered index, where you don't really need to sort the data by first name or last name and store it in the database. Instead, you can create a bucket which will say, hey, names starting from A, okay, starting with the letter A, B, C, D are stored in these rows. Those are alphabetically sorted, so that when you run a query, if it sees a non-clustered index column in the query, it will directly go to that index and get that sorted the row numbers and then pick them directly and then club it into the result set. Okay, so mostly non-clustered, most of the applications require non-clustered index actually for performance reasons. Okay, a table can have more than one non-clustered index, but it can have only one clustered index. Okay, so non-clustered index is a logical index, clustered index is a physical index. So you have to remember that. Okay, so and then you have to understand one of the biggest drawbacks of having an index. Okay, so what happens is when you insert a record into a table, okay, that has a primary key defined, okay, okay, again, if it's an auto increment, you are really lucky that your record will be stored as the last record in the storage. But if your primary key is a string, okay, with which you generate based on some combination of columns. For example, if I have customers from multiple countries, okay, I want to have a primary key something like country, state, and then the number. Okay, for example, if I have customers in US, I want to have a convention like US TX for Texas, and then 001 US TX 002, and again if I have a customer from California, which I'm inserting now, US CA 001. Okay, so what the database system should do is it should actually insert this US CA 001 above US TX 001 because it has to be sorted in the primary key column order, and this sorting will take time because it has to go back and update the indexes. Okay, the clustered index saying, hey, the sort order is now changed. The first record in the table is no more US TX 001. It's actually US CA 001. Okay, so when you have indexes and if you do bulk insert, okay, it will, even if a table is having millions of records, or if you try to insert one record, it will have a slow performance. Okay, so you should be very careful when you use index. It's generally not recommended to create too many and the same happens to non-clustered index too. If the table has both clustered and non-clustered, every record that is inserted has to sort both the clustered index and the non-clustered index. In the sense, it has to build both of them again. Okay, so the way people do bulk import is they actually drop all the index and then they import the millions of records into the table one shot, and then they run commands to recreate the index, and the database management system recreates the index. Okay, so whenever people do very huge amount of data import or data delete and other things, they drop the indexes and then they recreate it. Okay, so this is one of the downsides of index, so which is a very important retrieval question. Views, as I said, it's derived from one or more table. It's mostly used as read-only entities. People don't update tables using views, as I told earlier, and it's used in reports to show. And the last thing is, it is also one of the ways in which you can virtually normalize a database. Okay, if your data is redundant and multiple tables and other things, and you want to kind of virtually normalize without changing the underlying table, you can do that using views. And if you have those views, and if your application is, let's say, mostly reporting, you can import that into your ORM system, object relational mapping, instead of the actual tables, so that the schema looks much more clear for applications to infer and use. Okay. Stored procedures, again, it's a procedural statement. It's just set of SQL statements that you club and give a name. Okay. It contains mostly DML statements. Okay, but sometimes DDL statements are also used, say, to create temporary tables and other things. It can contain business logic if you want, and also it is compiled and granted execute permissions. So every time when you run a dynamic SQL query, your application has to go through this compilation to check if the query is correct, and then it has to check whether this particular user has permission on these objects and other things, and then it will execute the query. So there will be a delay if your application is using dynamic SQL, like passing SQL as a string to the database system. But if you are calling it as a stored procedure, it will be much faster because all the compilation is already done, and then one-time compilation is done, and then the permissions are also mapped, so it will be much faster. So it is generally recommended to put things in stored procedures. And also one of the drawbacks is people use object relational mapping components in their applications. Or what happens with these is sometimes these ORM layers also have bugs, and they introduce incorrect SQL statements when you try to search some records, emit in the sense. So that creates a lot of problems. So in some cases, for complex operations, query operations, instead of using the ORM object relational mapping queries, we actually use stored procedures to call them. And custom data types, again, you may need your own set of data types that you want your applications to use. So this is specific to the applications, and the main reason for this is to enable reusability within SQL programming and also port that to your application. Normalization. Okay, so this is a brief concept. I'm going to give only very brief overview, but you have to reference books to understand them in much bigger picture. So basically what normalization is, you are organizing the tables and columns to eliminate two things. One is redundancy, the other is dependency. Okay, unwanted dependency. There will be dependency, but unwanted dependency. Okay. So the main thing that happens is divide large table into small tables. When I mean large tables, it's just table with too many columns. Okay. So you just split them into multiple small tables, and you establish a relationship between the tables. So that way you eliminate redundancy. Okay. So for example, your table might be storing state, country in a lot of tables, and everything will be like inconsistent. For example, some people will store country US, United States US, or something like full form like United States or USA. To avoid these things, we create a master table and then let the other tables know you just reference the ID of this country or the state from this table. Okay, so that way they don't store the data redundantly or in different ways in different tables. Okay. And the ultimate goal of normalization is to organize the data, to insert, update, and delete data from one main table, delete the records from other related table through relationships. Okay, so if I delete a customer, I want to delete all his previous orders, it will automatically be deleted using cascade delete. Okay, again, be cautious when you try to issue a delete statement from the application or the query. Make sure there are no cascading delete constraints available set on the database system. Okay, I will show you what these are when we do the demo. This cascading delete will actually delete records from all the other dependent tables. Okay, and without you knowing that. Okay, this may sometimes lead to some problems. Okay, and again, one of the good guidelines is people don't really delete any data from database. They actually mark it to be deleted using some flags. Okay, I will explain how that can be done. Okay. So that's all for this session. Hope to catch you with a practical session. The next session will be, we will be validating these cards rules against Microsoft SQL Server. Okay, to show you how these cards rules are implemented in Microsoft SQL Server. Again, thanks for your time today, and let's catch up in the next session.